There's two basic sources of data that OmniCenter gets. Pulled data is primarily what we use for the time series and performance data, and this is data that we're going out and collecting from devices by querying them. And we use protocols for that like SNMP, WMI. It can be calls via an API. It can be direct connections to SQL. It can be Windows event log can even be pulled down this way. And we take that data into OmniCenter into our database and process it for alarms and alerts. The second major data source is push data, and this is data that we get sent to OmniCenter from devices. We don't control the timing of it. These are protocols like syslog, NetFlow, or SFlow, or SNMP traps that are just being pushed into OmniCenter by other systems when they've got something important to tell us and they want us to generate an alarm based on that, or log that information, or process it for an alert. There's also an API that allows you to push data into OmniCenter to integrate with things like service check. So, if a backup job fails, you could have that script send OmniCenter an alert and have it generate an alarm based on that. Just to kind of illustrate that point, pulled data, typically it's going to be, we're looking at a managed device, we're querying it, we're doing it at a regular interval. Every few minutes, we're going to go and kind of repeat that same process where it's going to go through and query that device and pull the data down, save it to the database. Push data, on the other hand, just comes to us without any solicitation. We just have to be ready to receive it and process it as it comes in. That performance-related data that we talked about is generally pulled data. It's data we're collecting at regular intervals. And whenever you see a graph like this of time series data, this is performance type data. This is the stuff we'll set thresholds against. You can also do things like run top talkers reports on it, or store creative custom reports based on this data and kind of export it that way. You can even use this data for kind of real-time comparisons to look for correlations and problems in the environment. We store the last 3 years of history for all of this data, but it does roll up over time. So the further back in time you go, the less granular the data becomes. So the highest resolution data is always kept for 100 days. So basically the last quarter plus a little bit, we'll always have the highest resolution data. After that, we roll that data up into half-hour averages, which are stored for just over 6 months. And then it rolls up into 4-hour averages, which are stored for the full 3 years. This allows us to store a lot of history and kind of keep the most recent history, the stuff that's most useful for diagnostics and troubleshooting, as granular as possible without having to use giant amounts of storage to do it.